Have I shown you this slide before?
Mm,
You have seen it before?
yes, I guess. Yes. Yeah, you have shown me this.
Okay. So basically what happens is when you're taking imagery from drone, because you know the possible bands that you have with in the drone that, for example, you have blue, green, and red in your drone, right? You have the
Mm,
possibility of near infrared also. Other sensors are also available, but they are like you have to pay something extra and that then so it depends on your budget and your application that which sensors you're gonna use and which bands they include, right?
mm,
So there is because on the basis of the band, what happens is if we have a single band, we are not able to differentiate between things that very well. So
mm.
so we are not able to differentiate between things that very well. So what we do is we based on the properties of bands, we when we have a single band, maybe for example, here there is vegetation and there is fellow land. So the person is not able to differentiate between the two in this single image. But when we
Mm,
are using a combination of image, what happens is due to different properties of the object in different bands, the combination of the images is kind of able to help us understand the information about the object more.
okay.
So, for example, the vegetation has high reflectance in near infrared, and as compared to near infrared, it has low reflectance in visible. So
Mm,
that is if we use two bands. Yeah. So we just started the class. What I was saying is, ma'am, what I was saying is just like a normal satellite. Similarly, in the drones, we have the possibility to have these bands. It depends on your budget and your application. So, for example, some drones are just equipped with RGB band. Some drones are equipped with maybe near infrared also. So you can add LiDAR also. So it's depending on the use case, which bands you use. So, but what happens is uh, when we have a single band, for
Sir, please
example,
back
maybe,
to slide. One thing I want. Yes, yes. No, this. No. Lancet and Sentinel.
yes, ma'am.
Yes. Sir, can you explain?
Okay. So I was just using this slide for the reference to explain how drone, I was just going to explain about NDVI, but okay. So what happens is, in this slide you see we have two different optical satellites, that is Landsat and Sentinel. So the current version of Landsat we are using is Landsat 8 and 9, and Sentinel is Sentinel 2. So what happens is the capability of the sensor in the satellite Landsat, it is kind of it is able to take the image of Earth in nine different wavelengths, that is nine different bands. Similarly, Sentinel is able to do it in 13 different bands. The range of the wavelength is from this to this. Now, what happens is Landsat has a resolution, the pixel size of the pixel size here, like the pixel size is 30 by 30. Whereas in Sentinel, the minimum, the highest resolution that is available to is 10 by 10. So some bands are 10 by 10 pixels, some are 20 by 20, some are 60 by 60. So there is a difference of the size of pixels. So this is the revisit time. So for example, uh, on Earth, if there is a place the satellite is visiting us today, it has a view of us today. So it will visit us again after 16 days. The Landsat will visit us again after 16 days. Whereas the Sentinel, uh, it it has a temporal resolution of 10 days. I think the speed has changed. The Sentinels, sorry, the Sentinel's temporal resolution is now, I think, changed. Maybe we can have a look. So it is a combination of two satellites, Sentinel 2A and 2B. If you talk about a single satellite, it has a revisit time of 10 days. Whereas in a combination of the satellites, you are getting a satellite revisiting you in 5 days. So here we are just talking about Sentinel 2A, but now we also have Sentinel 2B. Sentinel is owned by the European Space Agency, whereas Landsat is owned by the US Geological Survey. Now, both of them fall into the class of multispectral. So, what happens is, if you look at just the single band of the imagery, just the single band, if you just take a red band, so you will get a, maybe if you see this is the vegetation here. And if you see here in this, the water, it also has a similar reflectance value. So now just think, if I don't give you this colored images, if I just give you this image, will you be able to identify it if it is water or vegetation? No, because both have kind of similar digital numbers. So what do we do is, in that case, there are many examples that if we have a single band, we are not able to take out much information about the object on Earth. So this was an example of red band. Now, for example, if I have near infrared band, now here the vegetation, it is giving a DN value of, the pixel value is this much, whereas a fellow land, the pixel value is this much. So in the colored image, because it is a combination of RGB, you are able to differentiate them. But in a single band, you're not able to kind of differentiate the objects. So similarly, if you have snow and cloud in an image and you're just having a single band, you won't be able to differentiate like if this is a snow or this is a cloud. So what happens is, the how every object behaves to the reflectance in every wavelength is different. For example, the reflectance of vegetation in near infrared is very high, whereas its reflectance in visible is compared to it very less. So similarly, every object, for example, soil has a very high reflectance in high infrared bands, whereas in visible range it is very low reflectance. So similarly, and for water you can see beyond NIR red, NIR near infrared, it is not even giving any reflectance. The reflectance is almost zero. So it is also called as the spectral response of the object. Now, because in one band we were not able to differentiate much of about information about the object, we take a combination of two bands. So what that means is, uh, when we are using two bands, the combination of two bands, we are able to create some indices. So, for example, if I have a band in IR and if I have red, so I know the reflectance of vegetation in NIR is high, whereas the reflectance of vegetation in red is low. So we created a mathematical operator that will have a value between -1 to 1. right? So this is kind of a mathematical operator created just to have the value of NDVI or any band ratio. So what we are doing here is we are restricting the value between -1 to 1 for us to understand if the value is near 1, it means uh, high reflectance NIR. That means NIR value is more than the red one. So what it means is more the value is near 1, more the uh, vegetation is good. So we have to take more than one band to be able to get information about the object on Earth. So, and that information is based on the character of the object, uh, how it is having the reflectance for that particular band. Maybe if
Not able to hear you, Akshay.
it is not having high reflectance in red, but band ratio would be not useful to us. Hello?
Yeah,
Uh,
we can hear you now. We lost you
uh,
for some minutes.
what? Okay, just a moment. Let me check my internet connection again. So what is happening is that we need at least two bands to be able to understand the information about the object on Earth. Now, what if
Why? Why the? Is there anything um apart from red we can give here, like blue or green?
so you have to check for the object, for example, um, now see if for vegetation I see it is low in this region and it is high in this region. It is high as well as this region. Other
Mm,
than NIR, you can maybe use this thing. Maybe instead of red, maybe you could use whatever this wavelength here is. So you can uh, change according to the wavelengths. But there needs to be a notable difference between the character of the wavelength in two different bands. So what if you choose both bands from this region only? Then it will not be possible because when you will minus one minus the other, then it will not give any prominent values. So you need to have a notable difference here, right?
mm. But how only three bands? I mean, red, green, and blue. We need to minus from NAR, correct? This is constant.
No, no, I didn't get you. Why just these three?
Like, mm, because this is the visible light, right? The
No, are you just talking about vegetation?
yeah. No, not only for vegetation, for every calculation like snow, water.
No, 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 no. So what I'm telling you is, so see for now, just try to understand it again. You have a band spectrum. You have the capability to have bands anywhere in this whole spectrum, maybe
Mm,
visible, infrared, microwave. So you
mm,
have this complete spectrum where you can have the wavelength, right?
mm,
You are
mm,
not restricted to just so now. when you have maybe this is any object on Earth. That can be snow or vegetation, any object on Earth. So there
Okay.
is a band, maybe this is called as band A. It could be
Mm,
any band, right? Any band.
mm,
Now,
mm.
this band, when it comes here and it gets reflected, so in this particular case, this highly reflects it. Like, so if 100 units of the energy was coming for this band and it reflects 80% of it,
Okay.
so there is high reflectance, right?
Mm, mm,
Now there is another band that is band B.
mm.
So when 100% of it comes, the character of the this object is as such that it only reflects 20% of it.
Okay.
This is the character of this object, that in this
Okay.
wavelength it is behaving like this,
Mm,
in this wavelength it is behaving like this.
okay.
So we need two wavelengths, we need two we need two bands where the difference of reflectance is high.
Mm,
See, 80 and 20. If the other
okay.
band B was also giving 70, then it was not useful to me.
Mm,
So now, particularly when we look for when we have the object as vegetation on Earth, when we talk
okay.
about vegetation and you look at this graph, so in vegetation, the reflectance is low in the visible range and it goes very high in NIR. So if you don't want red, you can take whatever this wavelength here it is. Maybe it is microwave here or something. You can take this also because it is low here. So you need to just take a combination where, because we took visible because it is easily available in all the sensors. This is
Mm,
very
mm,
difficult to get here.
mm. Yeah, that's what. The visible thing, it is red, green, and blue, correct? So
Yeah.
in that very low, what we have is the green square you have
So
on
it
the
goes like this.
uh,
RGB. So infrared is this side near the red. So where did it go? So this one is red, 3 is red.
mm,
Uh, this is 2 is green and 1 is blue.
okay, okay, that's what I just wanted to check.
Yeah,
So very low, whatever we have, we need to pick that up.
yeah.
Okay. In this case, so for water, we should give the first one, correct?
So for water, I would say, because you see there is not much difference. It is only in 0 point something, and if you have to perform such analysis, I would take even like it.
One is very comparatively two and three. One is very less we have, right?
So there is. Let me check which bands are used for water. So there is NDWI. It is NIR minus red. So what they have done is um, they have taken it in a reverse way now. So
Mm,
this is a high value here, right?
mm,
And this is a very low value here. So
mm.
they have used it the other way.
Okay.
Yeah. Now, uh,
So who defines this? Like to take this one red, is that globally it will be the same, or else for our convenient we need to change this red to
no,
green?
it is already defined. Um,
Okay.
so there is this index database. So it has all the defined indices in the world, all, like
Mm.
everything. So you can find every defined indice. The formula is here.
Is the name shows the objects, or what it is? Is these many objects in the earth?
Yeah, it is mostly to kind of understand the object on Earth. For example, if you need to have and look for dolomite in a region that is a kind of rock, then you would use this. If you need to understand about the chlorophyll in the leaves, then you use these formulas. So all of these are kind of based on the application of what you
Mhm.
want to look for.
Okay.
So maybe NV5 has some. So not all the indices are common, but for example, and let me check LMN. Yeah. So I think NV5, this website has more clarity about the indices. If you and they also explain what it means.
Mm.
I'll share this with you. So what we get from this NDVI thing is now we get the values between -1 to 1. So we have the values ranging from -1 to 1. Now what it means is if you have 0 point value that is 0.66 to 1, it means the plant is healthy, the vegetation is healthy. If it is 0.33 to 0.66, it means moderately healthy plant. And if it is from 0 to 0.33, it is unhealthy plant. And -1 to 0 is either dead plant or inanimate objects. Now, generally, to be on safe side, we take the threshold as we take the threshold of zero point 0.2. That means if it is greater than the value is greater than zero point 0.2, then only we can think of it as a plant. Otherwise, we are not sure if it is plant. So any value less than zero point 0.2 is can be anything.
Mm.
So as it says here, negative values correspond to areas with water surface, man-made structures, rocks, clouds, snow. So here it can be anything among these. Similarly, we have, uh, for example, for snow. So in snow, if you think for snow, we have high reflectance across all visible wavelengths and low reflectance in uh, SWIR. So this band, if you see, it has low reflectance, whereas it has high reflectance here. So you can just make a combination of this and this. So in general, mm, green and SWIR. So we use a combination of green and SWIR. These are some indices that you may have a look. The formula is here. So most commonly used one is NDVI, and after that we also use NDWI, snow water index, NDSI also we use. So based on your requirement of the object that you want to understand on the earth. So similarly, it's with drone. So when you have a drone, you will be able to get RGB. If you need to be able to kind of decode information about a particular object or its properties, so you will have to have um you will have to kind of do these indices. So if you have a good drone software, they already are fitted with all the indices. So they will automatically give you the NDVI, give you automatically the NDCI, NDSI. But if you have uh, a very open source or general software, then you have to calculate these things by yourself.
Okay. This water ration index is what is the difference? Like water ration index and automated water extraction index.
This is even I have to look for the difference. Uh, okay. So when you have like maybe you have a drone imagery or satellite imagery, you want to extract out water bodies, like you want to extract the lake out of it, you want to extract some water bodies and mm, demarcate it. So in that case, you will be using this automated water extraction index. So when you use this index, either you will get like there would be uh, so what it means is if the value is greater than 0, it
Mm,
is water. If the value is
mm,
less than 0, it will be non-water. So you have two classes. One is water, one is non-water. So you are able to extract water out of it. Whereas
mm,
in the water ration index, you get to understand more about the vegetation moisture. Like in the vegetation also you have moisture. Also you'll be able to map water bodies. So these
mm,
are different in their application. This is more of kind of extracting the like deciphering between water and non-water. This is more about
mm.
water plus moisture. So there are in you will find thousands of indices on water. So it depends on your application, how to use it for what your purpose you're using it.
Okay.
Now, for example, there are many vegetation indices they can be used for mapping, monitoring, biodiversity assessment, biophysical parameters, phenological assessments, vegetation. This is the most wide application of the
Mm,
indices, forest degradation, crop condition, productivity, yield, right?
okay.
So maybe we will try to is do an example of calculating NDVI. So if you go to this website, that is, if you write on Google USGS Earth Explorer, and you just do it simultaneously with me. Have you downloaded any data from here before?
Yeah.
Do you have it with you?
Mm, let me check. Yes, I have one.
Okay, we'll do that, but let me also explain, ma'am. Ma'am, this is the website for USGS Earth Explorer. We need to go here, and to download the Landsat imagery, we need to kind of create a login here. So when you click on login here, it will take you to this place, and you need to create an account to be able to download the Landsat imagery.
Yes, sir, I
So,
have it.
okay, ma'am. So once you log in, for example, we will look for a region in India. Maybe here in World Features, I'll search for Chandigarh. I'll select the area. So it shows me the marker. Once I'm at the area, so I'll choose my region of where I want the data from which I want. I'll use the use map here. So after zooming out, I can change the points as per my requirement, and then select the date range. But for me, I'm maybe looking for latest data, so I don't need to add a date. You can select cloud cover. Maybe we want less than 40% clouds. So we can go down data sets. Then we go to Landsat. And here we see Landsat correction 2, level 2. And we select this Landsat 8 and 9. And we click results. So if you see, I have many images in my result. So if I want to see the footprint of the image, how it looks, I can just click here. So this is the size of the tile. And if I want to have a review overview of it, I click this next one. So it gives me the how the image will look. Now, what we will do is we download any one image that looks good and there is no cloud cover like this. There is the blue thing is the cloud cover. So if you see this, there is so much cloud cover. We don't want cloud cover. We download an image which is without cloud cover. Once you click here, and in product options, you have the option to download it completely. Now let me first check if I have one in my PC. Just a moment. Mm. So I have a downloaded image before with me. Now, if you see in Landsat, uh, Now, if you see for Landsat, the band 5 is here near infrared, and we want the red. So we will be working with band 5 and band 4. Whereas if we would have been having the Sentinel-2 data, then instead of band 5, it is band 8. So we would have chosen band 8 and band 4. Now, here the product will be of a resolution of 30. Here the product will be of a resolution of 30 meters. Whereas in Sentinel-2, if we calculate NDVI, we will have a product that is of 10 meters resolution. So it is pretty much obvious that uh, both are freely available. So if you have to calculate NDVI for a region, it is more preferable to do it in and Sentinel-2. Now, uh, if you open your QGIS, if you go to your QGIS and you now we know that for Landsat it is layer 5 and layer 4. So you go to add layer, add raster layer. You go to your folder where the layer is. You select band 5, add it. Then you again go add layer. Then add band 4 and add it. Now you see that you have both your bands here. That is band 5 and band 4. Now, there is one more thing. Maybe I will also load one band to 5432. I've also added 3 and 2 just to show you something. Now, if I choose a combination of band 432, it will kind of give me a true color image. It is why is it not working? I have to load the image in my So we can, with the combination of these bands only, we are able to create a true color image, like how it is actually looking on ground. Uh, Now to calculate NDVI, what we are concerned with is we are concerned with band 5 and band 4. So here we go and we look for raster calculator. So we choose this second one in raster analysis, the raster calculator. So we give it the input layer as we choose layer 5 and layer 4. We add it. Now we have two layers. Now we have to give the expression. So in this expression, now since we know the formula of NDVI, I'll choose NDVI minus red band by NDVI plus red band. So similarly in raster calculator for any other indices, you can just simply select your bands, whatever band is used in that indices. If you need NDSI, you can look for SWIR and green. So just from the bands itself. So similar it is with drone. In drone, you will have the bands that you need, and based on the bands, you can either the software has this option in it, or if you have to do it manually, you just go here. So if you want to save the file to your computer, save file and run. So now I have NDVI. So what it means is now in this you can see clearly that I have until 0.5. That means it may be the season or whatever. Uh, it may be the region or the season. I have just only these three classes. I don't have very healthy plants in my region. So it might be the fall, so because of which the plants are about to weather out, or maybe uh, it is like the very start of. So depending on the season, also you have the NDVI values ranging all across the season. So now, how to visualize this NDVI? You just go to symbology here on the layer settle and you choose single band pseudo color. And here you choose maybe equal intervals and classify. Make the classes maybe 8. Now, if you look here, you are clearly able to demarcate that this green area is plants because it is near 0.5. So this is vegetation. And for example, this was a lake. So it must be having a value in negative or Yeah, so it has a value in negative. So similarly, this all is built up area. This is a city. It has value less than 0.2. So for it to be a vegetation, it has to have a value of higher than 0.2. This is confirmed vegetation. So similarly, we are able to kind of do the same analysis for different kinds of indices. Okay. Any doubt in this?
No.
Hello? Okay.
So the bands we have choose four type of bands, right? Here the left band.
No, no, I just added it to visualize something, but we just need only 5 and 4 only. So in the equation that I used, I just used 5 and 4.
Mm. Okay, NIR and sorry SWIR and red one, correct?
No, no, NIR and red one.
Okay. So then what is SWIR? Is that different from NIR, right?
Yeah, it is like in the wavelength, if you see. So this is called as shortwave infrared, and this is near infrared.
Mm.
So the difference is they both belong to infrared region. It is just like we have different kind of invisible, and we have green, red, and blue. So in infrared we have NIR, SWIR. So we there is the difference of wavelength,
Mm.
right?
Okay. So on while doing equation,
Mhm.
on doing the math part, we either
Mhm.
use to SWIR or NIR, correct?
Pardon?
While doing that formula and the calculation,
Mm-hmm.
like NIR minus red or green. So whether we
Mhm.
need to choose any one, right? NIR or SWIR.
So it depends on the reflectance of your product.
Mm.
So if your object has a high reflectance in both NIR and SWIR, you can choose any of them. But if it does not have a high reflectance in SWIR, but has a high reflectance in NIR, so we'll choose NIR then.
Can you show me how to choose that one? Uh, SWIR and NIR. The difference of
So if you see here, so this was the visible region here.
mm,
This is the infrared region here.
mm,
Just like in visible, we have these different wavelengths.
mm.
Similarly, in infrared region, we have these different wavelengths. That
Okay,
is NIR, SWIR, MWIR. So, because your reflectance was very low in red, we chose red. It was very high in NIR, so we chose NIR. If it is not high here, it was high here, then we will choose this. So, depending on the band it is higher, we will choose that band.
okay. In the scenario, we choose this vegetation part, right? You have showed the example,
Mm-hmm.
the fallow land. There, how we have identified to use NIR and SWIR. Here. You're here.
So you're saying how we are using here to.
Correct. Correct.
So what I'm saying here is in this image, he's saying he just has NIR, right? And he's
Mm,
not able to differentiate. So
mm,
when you use this NDVI, what will happen for. So it says it generally resembles of the bare soil. So if you look here, so just think this is the fallow land, this soil one, right?
okay. Okay.
Now you have very high value of vegetation here and difference here. So, and you see that just making out vegetation as different, you will be automatically able to uh, understand which is vegetation and which is fallow land. So
Mm,
here the properties of fallow land are not much of help. We are just using the properties of vegetation in NDVI to understand the difference. The result will tell us if it is a fallow land or if it's a vegetation,
mm,
right?
yeah.
Okay. Now, the most important thing is the um, kind of symbology you give it. For example, if I maybe choose something that is more expressive, maybe a single color. So now I know that this bright region is the vegetation, whereas the region other than that is all something else. So it's the visualization of it, the symbology. So how clearly we can see the river water here, see, because it's the negative value. So if maybe if someone asks me to differentiate between water and vegetation, I would,
Mhm,
in that case also, I will not be using NDWI, but I would rather use NDVI because it is more clear here.
mm,
So what comes next is, mm, so if you have to visualize, like if you go to this website, if you write Sentinel-2 download, if you go to this website
yeah.
and you click on explore data, so just select the, just maybe move to first Indian region. Just first move to a localized region and then uh, just look for what dates the data might be available. Select maybe October. What is happening to it? So if you click visualize here in the configuration part or where it was, hmm, just a moment. Yeah. So just select your region, and in your region, if you select for this second option here, this one, just select this option. Now here, now there is a combination of bands. If you see 432, it is the true color. If you want to see how it looks in false color, it is loading. Similarly, if you want to select NDVI, in dates, you need to select any one within the boxes, and then you come back to visualize, just select any date, and if you click here, you can see false color, you can see true color. So this is just a combination of bands. So NDVI here, if you see the formula is written here, this is the NDVI. This more green means more colorful vegetation. So if you want to click on moisture index, you will see how the moisture varies. So you can see very carefully here, there is might be some river or lake.
Mm.
So if you want to visualize just SWIR bands, if you want to look for NDWI, so there is NDWI. In NDWI, you are so in some other band, I was thinking if it is water. Now with NDWI, I am clear that it is not water. It is having maybe high moisture. Maybe it is some kind of crop or something, but it is not water exactly. So NDWI clears my doubt about it. So this is water. This is Gobind Sagar Dam. So visualizing the area in different indices gives different kind of inferences or information about the area. Now, if you want to, if you click custom here, you have NDSI also, but it is not, it will not be used here. It should be worked. For example, if I move to somewhere where there is snow, so I have snow here. Now if I use NDSI here, so it is clearly demarcating me. So the blue thing is snow, whereas the white thing is clouds.
Mm.
So you are able to get a clear demarcation. So you just go to kind of customs here, and in customs you can add any band combination you want. So you can explore the band combinations from the place I mentioned to you. So maybe I want to, okay, this is not the band that we can use here. NIR2 minus, this is based on worldview band, so not on Landsat. But you could just try here anything like just click on indices, just add anything band 9 minus band 11. So band 9 plus band 11. You can try any combinations. So this is just giving you the built up area maybe. So band 4 minus band 7, it kind of demarcated this layer of water for me. So in Sentinel, band 4 is red and band 7 is vegetation red edge. So maybe based on their properties, something came up. Also, if you want to create a composite of bands, how they look, you can just maybe look here in three different bands when they stacked together, how they will look. So 432 is the 432 is the natural color. This is how the earth looks. And if we take 543, it is called as the false color composite. This is the false color composite. So, but I think in case of Sentinel 2, it will be 843, I guess. Yes, 843. Yeah. So here you can see the vegetation is so highly, the reflectance of it is represented in red because of NIR. Then you have this custom where you can kind of add your own formulas here in the script, and maybe you can use all these here, and you are able to directly download from that website. Okay, until here, any doubts, please?
No, no.
Okay.
Can you share this PPT?
Which one? This one?
The previous one that NDVI shows.
Yeah, sure. Maybe let's give you an outlook of.
S2 and Quadbin. If you've ever heard these terms, you know we're probably talking about spatial indexes. So what are they and how can they actually help you do spatial analysis a lot more performantly? Spatial indexes are actually global discrete grids, which means that they cover the entirety of the globe and they have various levels that go up or down depending on where you are at. While this might seem similar to a geohash or other gridding systems, they have a couple of advantages that make them really, really useful for spatial analytics. First of all, spatial indexes are very efficient. That means you can process and query data much faster, and ultimately your
This is probably something else, but that was indexes. We are talking about indices, right? So, okay. Other than this, I don't think we have much to. If this is kind of helpful to you, you need to know that is what happened was there was this Open Geospatial Consortium, that is OGC, which takes care of every kind of standard that is to be produced in the GIS and remote sensing industry. For example, what I mean by standard is if you see your bulb in your house, so you
Mm,
buy a bulb of any company that fits in your bulb holder. Why it is so? Because the bulb holder has been standardized by the government. Otherwise, every company would have produced their own bulb holder, and you would have been very uh, it would have been chaos to buy the bulb for that particular bulb holder. But the standard is there that the bulb holder needs to be of a standardized size. So
mm,
similarly in GIS, you need to have some standards. You need standards for attribution, you need coordinate system standards, you need drone imagery pixel size standards. So all these standards are defined by Open Geospatial Consortium. So
mm,
that is the regulating body of how things will work in the GIS industry, right?
yeah.
So
Okay.
they have standardized like GML, KML, WMS, WFS, and because of this standardization, we have been able to kind of create the web GIS in this world. Now, what happened was their data is ISO registered. So if you go under the ISO number this and this,
Mm-hmm.
so if you look for the documents pertaining these ISO documents,
Okay.
so you will find information that that is all about how to create data for GIS.
No.
So for example, you are a new company, you want to kind of create your own software or something, then this will be the standards for you to understand. So this is kind of the uh, legal overview of what you are allowed to do in GIS and remote sensing, right?
Okay. So
But
it is ISO is Indian standard.
no, no, no. It
Uh,
is ISO is a world standard.
oh,
International.
okay.
So International Organization for Standardization.
Mm,
So they have these numbers, whatever this means is. So our particular number to look for GIS standardization is these two, and also maybe there are sub numbers to it. I saw this, and after that something else. So there are kind of national and international organizations like Inspire, FGDC. They work for the promotion of these standards that you should follow them. So this was all started when United Nations Statistical Commission, that is under the United Nations Statistical Division, that came into effect, and they were like things should be standardized. So it is kind of a global geospatial information management initiative, right?
mm.
So there is something called as spatial data infrastructure. For example, what what we understand about infrastructure is buildings, highways, that is human
Mm,
infrastructure. So
mm,
geospatial, the infrastructure is the things which upon which it is built. So it is built upon the satellite imagery, satellites, drones, the analysis from it, softwares. So that all compromises spatial data infrastructure. So the spatial data infrastructure needs to have standardized formats for interoperability. For example, now what if I'm downloading something from Google Earth? It comes in KML. Then I have to convert it into SHP in my software.
mm,
So it is the standardization, it is the interoperability because of which I'm able to convert KML into SHP. Otherwise, the company would have made KML in such a way that it could not have been converted.
mm, mm.
So these are some standards among the how to say
Which can add up. Mm,
among the institutions, right? So they talk about their records and management. So this is one example of Australian infrastructure. So it is almost common for every country. Okay, and what else? What else? What else? I think I'm done for today. I don't have any more
okay.
topics. But if still you think anything you want to repeat or something,
Mm. No. Do you have any mean like learning um, like resources where you'll get
so if you
study
want to
self
learn
self
about this QGIS software, there is this QGIS tutorial. This website is this
facial
website.
thoughts on us there is
Yes, yes, yes. So this
okay.
website has almost everything that you need to know about QGIS. Almost
Mm,
everything. And
mm,
it has like it includes the data. You can download the data here also. It is having everything.
mm.
So this is more about QGIS and
He has Python and master in Python and all. What about the complete geospatial technology like machine learning? or some other programmings? Do you have anything related to that?
Mm, I'm not sure because uh, I think all the resources they're only on YouTube, but there is no structured way of doing it.
Mm, mm, mm.
Um,
Okay.
there are some websites, but for example, so if I remember, yes, this is one website that will take you to kind of very good level of Python skills in spatial
Mm-hmm.
domain. So it is open
Okay.
source and you can start by, it starts like with the very basic of what you need to do, how to start in
Mm,
Python, then understand different libraries, how to do all these in, how to do all these processes in Python.
mm.
So I remember this one. There is one more, I am not sure which one it is. Maybe it was Spatial Thoughts only. Uh, maybe it was this only. I'm not
Mm,
sure.
mm. Okay.
But I've gone through this one. This is very good resource.
Oh,
Also, there is this one book about, yes, this one.
okay.
This is a very good book. Maybe you can,
This will be useful for the developer, right?
yeah.
Developer. Jeez.
So maybe, but you can look for it on LibGen. The book is not available here.
What is this? Freeware? I mean, a free site to download the book, ebooks, or
Yeah, you
uh,
can just download any
okay.
book. I mean, just write a keyword of, for example, geoinformatics. So you can download many research papers, many books. So there are books.
Mm,
You can just directly download it from here. Applied spatial analysis and policy. You can select from here if you just want any particular thing. Uh, for example, my favorite book in geology is Plummer. So for me, I just physical geology and then I
mhm,
search by the name of the author, physical geology,
mhm.
Plummer. Mhm. So I have the book here. Physical geology. So this is where I can download it directly.
Oh,
So the book has started downloading.
mhm.
Okay, then I will see you. I don't know if your lecturer will be there from tomorrow onwards. If in case he's not there, maybe I'll take the lecture, but then I will probably work with some exercises. We'll do some practical exercises instead of theory then.
Mhm. Okay.
Oh, okay then. Well,
Okay. Thank you. See you.
yeah.
Bye.